very warm greetings to all my dear students. In this video, you are going to solve on simple DIT FFT problem. Okay. So in the previous video, I have explained you about the derivation part of DIT FFT algorithm and also about the butterfly flow graph. Here you are using butterfly flow graph in order to find out the x of k. Okay. First we'll see what is given in your question. So your question is x of n is 2 power n is equal to 8 and you have to find what is x of k. So in some other problems, x of n value will be directly given as a sequence. Okay, but here it is given in mathematical expression. You have to substitute the values of n in order to find out the x of n sequence. Okay, so what is the value of n? It varies from 0 to n minus 1. Here n is given as 8. So 8 minus 1 is 7. So it varies from 0 to 7. Okay. We'll substitute the value here. 2 power 0 is 1. When it is 1, it is 2. When you substitute 2, it is 4. When you substitute 3, 2 power 3 is 8. When you substitute 4, 2 power 4 is 16. When you substitute 5, 2 power 5 is 32. When you substitute 6, it is 64. When you substitute 7, it is 128. So this is your input sequence. X of n is equal to 1, 2, 4, 8, 16, 32, 64 and 128. Okay. So from this sequence you are going to find out the x of k value using butterfly flow graph. Okay. So in the DIT FFT derivation itself, I have told you about the bit reversal order and also about the derivation for twiddle factor values. Okay. Before solving this problem, you must go through the previous derivation video. Okay. Now let us start the flow graph. This is your first stage. This is your 2-point DFT, and the second stage will be 4-point DFT, and third stage will be 8-point DFT. So here I am considering the bit reversal inputs: x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. So you have to write the corresponding value. Okay. So x of 0 is 1, x of 4 is 16, x of 2 is 4, x of 6 is 64, x of 1 is 2, x of 5 is 32, x of 3 is 8, x of 7 is 128. So from here we are going to perform the first stage of decimation. Okay. So in the first stage it is 2-point DFT. So I am going to divide the sequence in 2. Okay. This is first 2-point DFT, this is second one, this is the third one and this is the fourth one. In 2-point, the first half will be normal, and in the second half I am going to multiply with the twiddle factor and also with -1. Okay, same way I am doing for the remaining also. So here we will see the equation part. First input is 1, we are taking from here 1. The next is 16 into 1, which is plus 16, it is 17. The next one, 16 into 1 into -1, so it will be -16, your answer is -15. The next one, 4, 64 into 1, which is plus 64, that is 68. The next one, 4, 64 into 1 into -1, so it will be -64, your answer is -60. Next is 2 plus 32, your answer is 34. Next is 2, 32 into 1 into -1, so you will get -30. Next is 8, 128 into 1, your answer is 136. Next one is 8, 128 into 1 into -1, it will be -128, so your answer is -120. Okay, this is your first stage. Next is second stage. In second stage we will have two 4-point DFT, first 4-point and second 4-point DFT. In this 4-point DFT we are dividing the first half and second half. So in the second half we will be multiplying with the twiddle factor value and also by -1. Okay. So as per the general structure of DIT FFT flow graph, I have done this one. So we'll consider the input as 70 plus 68, which is your 85. Next one, minus 15. Here we have w a power 2 is minus j. Look at this one. It is minus j. So you have to multiply with the minus j. Minus 60 into minus j is plus 60j. The next one, 68 into 1 into minus 1, it is minus 68. The value, second value is plus 17, which is your minus 51. The next one, minus 60 into minus j into minus 1. So minus into minus plus, plus into minus minus. So minus 60j minus 15. Okay, from here minus 15. The next part, next is second 4-point DFT. Consider 34. 136 into 1 is your 70, 170. The next one, minus 30. The second input is from here. It is minus 120 into minus j plus 120j. The next one, 136 into 1 into minus 1. So minus 136. The next input from here, it is plus 34. Your answer is minus 102. The next one, minus 120 into minus j into minus 1. So minus into minus plus, plus into minus minus. So you will be getting minus 120j minus 30. Okay. This is your second stage. And the third stage is 8-point DFT. In 8-point DFT, we are segregating the segment into two halves. In the second half, you will be having the DIT factor along with the minus 1 value. Okay. So the first will be 85. From here I am taking 170 into 1. So your answer is 255. The second one is minus 15 plus 60j plus. The second one is here minus 30 plus 120j, and your DIT factor value is 0.707 minus j, 0.707. So you have to multiply this whole term with this whole term. Okay. So I have written it here. The next one, minus 51. Here minus 102 into minus j. So it will become plus 102j. Okay. So minus 51 plus 102j. The next one, minus 60j minus 15. And from here you will have minus 120j minus 30 into the DIT factor value. Okay. This one. You have to multiply the whole term with this whole term and write here. The next one, 120 into 1 into minus 1 will be minus 170, and from here it is plus 85. Your answer is minus 85. The next one, minus 30 plus 120j. You have to multiply this one and along with the minus 1 value. So don't miss this minus 1. Your answer will be wrong. Okay, if you miss it. Plus the second input from here, minus 15 plus 60j from here. For the next one, minus 102 into minus j into minus 1. Minus into minus plus, plus into minus minus. So it will be minus 102j minus 51 from here. Okay. The next one, minus 120j minus 30. You have to multiply this whole term with this whole term along with the minus 1 value. I have written it here. The next input is minus 60j minus 15. So this will be your x of 0 and x of 1. Here I have solved it. This will be your x of 1 value and this is your x of 2. For x of 3, here I have solved it, and this is your x of 4, and for x of 5 I have solved it. This is your x of 6 and your x of 7 I have solved it here. So while solving this term, you will be getting j square. So value of j square is minus 1. So while solving these expressions, you will be getting j square. J square value is minus 1. Okay. So when you get minus j square, you will get minus into minus 1, it is plus 1. Please don't forget this. So you have to use these two values while solving the expression for x of 1, x of 3, x of 5 and x of 7. Since we have the twiddle factor imaginary part, it will be difficult to solve it. Okay. So you have to use these two expressions while solving this. Okay. So here I am writing the x of k sequence. This is x of 0 to 55. This is x of 1. Here I am writing it. This is x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. So, you can verify whether you have gotten clear output or not. Whether your output is right or wrong, you can verify it by using three statements. Okay. Your first statement is x of 1 is complex conjugate of x of 7. You can verify it. You will have 48.63 plus j. Here you will have 48.63 minus j 166. Here it is plus j 166. Here it is minus j 166. Okay. So next statement is x of 2 value will be complex conjugate of x of 6. So here you will have plus 102j. Here you will have minus 102j. Same way x of 3 will be complex conjugate of x of 5. Here you will have plus j 13.95. Here you will have minus j 13.95. Okay. So by using these three statements, you can verify whether you have gotten right output or not, right sequence or not. Okay. So I hope you have gotten clear idea how to use the butterfly stages in order to find out the x of k sequence. Yes? Okay. Thank you. See you in the next video. For the better understanding purpose, I am showing you this one. Please go through it. So this is to find out the sequence of x of n, and this is first point DFT, first stage of DFT. This is second stage, and this is third stage of the decimation. Okay. Here I have solved the values of x of 1, x of 3, x of 5 and x of 7. And here it is your final x of k sequence.